So this is developing apps for Apple Watch. I gave a presentation like this in December here, and since then I've been working on a watch app exclusively. So I have learned a lot, and this is a much better presentation than the December one. So I'm Jeff Kelley. I work here at Detroit Labs. I make iOS apps and now watch apps. I'm also in the process of writing this book, developing for Apple Watch. It should be out in the next couple months as an ebook. We're going with an ebook first while we wait for the native SDK to drop, because I don't want people to have to buy like 2 paper books within a year. That's just mean. So let's get into it. So that's the Apple Watch. Unless you live under a rock, you've probably seen some articles in the tech press about this thing. That's the one I ordered for myself. It's fancy. And the first thing as developers that we think when a fancy new device comes out is I want to build apps for it. And that's totally encouraged. So much so that on Apple's website, they're featuring third-party apps that other companies have made. We've got, I think it's American Airlines and BMW and Honeywell in the background. They were, all good with Nest until Nest got bought by Google. So now Honeywell gets all the love. And so today we're going to talk about building apps for this thing. Now there are 2 kinds of apps that will run on the watch. First is WatchKit apps. And these are bundled inside of your iPhone app. So when you install the app on your phone, it'll say, hey, do you want to install this on the watch as well? And then it puts part of your bundle on the watch. But all of the computation is on the phone. So every button that you press that runs some business logic, that all happens on the phone and is communicated to the watch over Bluetooth. All the UI objects in these apps are on the watch, and then you interface with a proxy on the phone. So when you say, for instance, change the text of this label, your phone tells your watch, change the text of this label, and it updates on the screen. So this is the MVC paradigm made real with actual physical devices separating the view and the controller. So if you don't like MVC, too bad. WatchKit apps, you can do things, whatever you want. You can make network requests. Almost everything is available. But if there's something you want to do that takes a long time, you can also ask the parent iPhone app to take care of it. So if your WatchKit app mines Bitcoin, you have the parent app do it and stay alive for at least 10 minutes as a background task. This is WatchKit apps, and it's also, so interactions are measured in seconds. So nothing you build is going to last very long in the user's attention. So you want to build something that they can use quickly and then go away. So we're not talking about like building Minecraft for the watch. We're talking about like building a Minecraft inventory checker for the watch. Then there are native watch apps, which are independent of iPhone apps. All the computation happens on the tiny little processor on the watch, and you can't make them yet. So right now, only Apple can make these. So like the fitness app on the watch is a good example. Later this year, whatever that means, this will come to third-party developers. I think that's not going to be WWDC because the watch just came out and most pre-orders won't even be fulfilled at that point. Probably like September or October, we'll see this. And then if you look at the Apple Watch app on your phone, if you have iOS 8.2 or above, there's an App Store version, or an App Store page in it. I think that's where these will be distributed. I don't think an App Store on the actual watch makes a lot of sense. It'd be very hard to navigate. So we can't make native apps, so let's stop talking about them. Some apps don't even need a watch app. So the easiest way when your pre-order comes in the mail and you want to see your app on the watch is to use push notifications. So if you use actionable notifications now, or any push notifications, they get sent to the watch automatically. So here's a test app I made called Actionable Notifications, and Jane has invited us to the launch party. And from the watch, we can accept, we can say maybe, we can do other stuff. And all that information is built into the push notification. And when you tap on one, it tells the iPhone app, the user push this button. You can also, if you have a media app, if you use the Now Playing info center, that will show up on the watch without you having to do anything, and it has buttons to control it. So if you use either of those two things, your app already works for Apple Watch, which is cool. So by default, the watch shows all the notifications from your phone. And if your phone is locked, it sends them to the watch. And if your phone is if you're using your phone, it just sends the notifications to your phone. If you make a WatchKit extension, which is how you build an app, you can say how they should appear. You can customize the look and feel of them. You can provide actions that turn into buttons. And the same actions that you set in the push notification will show up on the iPhone screen. So the same push notification that makes this screen on the watch will show up on the phone, and you can pull down and you see two buttons. And will show up on the lock screen, and you can pull to the side and also see two buttons. And that's all the same code in iOS, just showing the user actions they can take in a couple locations.
So why is it the maybe action gone?
What's that?
Why was the maybe action gone?
That's an excellent question. So I don't go into detail on push notifications in code, but you make a category of a notification. So this category would be like an event invitation. And you can say in your iPhone app, here are some actions for this category of notification. And in this case, you provide a context. So these two contexts are compressed. So you only can supply a couple of things. And then there's like a normal context. And the watch will use the normal context to show you all the options. You can also, if you have notifications turned on as alerts, so they show up as like an alert dialog, you also see the other options there. So WatchKit powers push notification customization, glances, which are tiny little bits of information accessible from the watch face, and WatchKit apps. And the UI system is very different from iOS, and you can only customize it so much. You can put your images in there and use provided UI components, but you can't make your own UI components. You can't do custom rendering or anything like that, and you can't do custom layout. So you have to work within the constraints of the system to make the app you want to make. You manage pages of content. They'll be called interfaces. Same kind of thing as a page full of content on the phone, but interface is the word we use on the watch. So a glance. If you're on the watch and you're on the watch face and you swipe up, you go to a list of glances. Every app can have at most one glance, so be sure to pick the best information to show on it. So this is, your user is checking their watch and they want to check like the most important thing in your app. So if you are working for an airline, like your next boarding pass would be a good thing to show on this screen, or your next event or your next to-do item, right? Like the thing they care most about for your app. And it splits the content into top and bottom groups where you can add certain elements to it. So here is an example of a glance. So we have our top area that says next meetup, and then our details about it right here. It's called WatchKit. It's here and it's today. So you'll probably want to make a prettier glance than that. But as they're swiping through, they just get a quick taste of the information in your app. So this is Xcode, open to interface builder and a storyboard in a WatchKit app. It looks a lot like storyboards that you're used to for iPhone app, but everything's tiny because these are watches. Each of these screens is a different screen in a watch app, and these are individual UI components of them. So do a quick tour of the UI, and then we'll see how the layout system works. So an interface controller is one of these little squares from the storyboard. That's one interface controller. As like a view controller on iOS, it manages a screen full of content. So this is the screen that has a button and a label inside of a button. Or you might have a screen for viewing a boarding pass, or a screen for editing a to-do item. You can present them in a hierarchy, so you can tap that button and go to the next screen, and then when the user's done, they can go back, just like a navigation controller. Or you can present them, so here's an example of that, where I get ahead of myself. So I can have this button display this controller, and there's a little back button that you can barely see. Or you present them in paged groups. So you could have an app that has your first screen, and then you swipe over to see the second screen. And those are mutually exclusive. So if you are currently displaying the second screen in a page, and you try to push an interface controller for a navigation stack, it won't work. You have to pick one or the other, because that could be confusing, right? Because if I was on the first screen and I push a navigation thing as a back button, and then I swipe left, I go back to the first screen. But now if I swipe right, I go to the second screen because it's on the page layout. That's very confusing, so you can't do that. All the views on the app are called interface objects. So it's kind of like UI view. It's now WK interface object. And they put themselves on screen. So you don't actually set the coordinates of where they appear or anything. You just put them on the interface controller that puts them somewhere. You can put them into groups for more precise layout. So instead of just adding them all to the screen, you can group them and move them around. And we'll see that in a live demo, either vertically or horizontally. The best analog to this layout system is HTML tables. So if you remember that back in the day, you could have like a table inside a table to lay stuff out exactly how you wanted it. WatchKit's kind of like that, but I think a little nicer because you edit things visually and not with a bunch of nested HTML tags. You can customize them in very limited ways. So in the storyboard, you can change a lot of things like the alignment of text in a label or how many lines it can take up. And then in code, you can only set very limited things. So let's take a label, for instance. You can set the text in code, but you can only set the alignment in the storyboard. And so a lot of the stuff in your app is done at design time. It's kind of interesting. And then most of them allow you to tint the colors to work with your brand. So you have labels. They have all kinds of built-in styles. You can use custom fonts and stuff. And there are two custom subtypes of it. There's dates and timers. The date object, don't use, you'll get rejected because all it does is it displays the current time and formats it for you. And I think along the way of developing WatchKit, Apple realized watch apps don't need to tell the time because it's on a watch and it's already telling the time. So if all your app is doing is telling the time, you'll get rejected. But a date object will display the current date and time and let you format it how you want. A timer will count down to a time. I forgot to change this slide. It used to count up, now it just counts down. So if you have like a next event in your app, you can set that date on the timer down there, and it will format for you how long until that time. So those labels, pretty straightforward. I'm going to run through all these objects, then we'll see them, we'll play with them in the storyboard to actually get a feel for how the layout system works. You can put images in, so this is WK interface image. Images are kind of weird because you can put them in many places. You can put them inside your watch app, and so the actual image is on the hard drive of the watch. You can put them in your extension, and then it's on your phone, and you have to send it to the watch. Or you can put them in the iPhone app and send them to the extension, and then send them to the watch. We'll see more on that later. You can make animated images. So the best way to do like really cool animations is just to create a sequence of images like a flipbook. So if you want a circle that fills in with progress on something, make a ton of images and then animate through them. There's no like live rendering. So a lot of the apps are using images with animations for like loading indicators. So You get someone to make a fancy animation, and you play it while you wait for something to happen. These are some buttons. By default, a button just has text in it. You can also put other things inside of it. So this button has an image and a label inside of it. You can make them smaller, you can disable them, and then you tap them in code runs. That's a button. Switches look a lot like buttons, but they can only be on and off. You can customize what they say and their color. And then when you switch the value, a method gets called. Pretty straightforward. I can go through all these because there's actually only 11 different interface objects in the entire framework to deal with, which coming from iOS is crazy. Sliders also have the same kind of appearance with a plus-minus button to change a value. So you specify a minimum and a maximum, and then you can put steps in there. You can change the images for plus and minus. And when you change the value, it calls a method. You can put maps in your app. Maps have a very interesting set of properties on WatchKit. You can't interact with it, so you can't move your finger around and zoom in, or you can add a pin to it, but you can't display information with the pin. When the user taps on the map, it opens the Watch Maps app on the watch, exits your app, and the center location, wherever you centered this map, shows up as a pin. So if you're making an app, let's say that finds restaurants nearby that sell tacos, what you want to do is center the map on a taco restaurant and then kick that out to the Maps app so they can get directions to their delicious tacos. If you have it centered on their current location and you add a bunch of pins nearby for taco places, they won't be able to go to the Maps app and get to that taco place. It's an interesting feature of Maps. Tables, kind of like UI table view, but they're very different, and we'll see that later. Each row that you make is an empty group that you can put other things into. So whatever you need in your table, labels, images, buttons. And finally, we'll talk about groups. Groups is where you actually start to get good-looking layout in your Watch app. So the entire job of a group is like an HTML table. It just contains things. So here's a horizontal group with 2 buttons in it. So you add them to it, and it just puts them horizontally one after another. So one button, another button. Here's a vertical group. First button, second button. And that's, yeah.
Can you put a vertical instead of horizontal?
Yep. So this example at the bottom is a horizontal group that has 2 vertical groups with an image and then a label.
Oh,
And that's how you can actually make watch apps that look good. So next up is menus. So on any interface controller, you can add a contextual menu that when the user force touches, still hate that name, when they force touch on the watch, it shows up to 4 icons, and those are either built-in graphics or custom. And then you can do whatever you want when the user taps those. So that was a lot of talking about all the different objects because I think going through them is only so useful. But I'm now going to show you what they're like.
Jeff, where do glances fit into the UI stuff?
So a glance is a special interface controller that you make. I will make one in a demo app. Let me start a new project in Xcode and move this over here so everybody else can see it. And then here. All right. So we're going to make a new iPhone app. Let's call it Demo. And so this is just a blank iPhone app, doesn't have anything to it. And we're going to add a new target, which is a WatchKit app. And this adds 2 things to our groups on the left. It adds a demo WatchKit app and a demo WatchKit extension. So the app portion is what gets sent to the watch and lives on the watch. So this storyboard that has this notification interface and this interface controller here, that storyboard lives on the watch. So the extension does not know how everything is laid out, but the watch does. There's an images.exe assets, so any images you put in here are stored on the watch. In the extension are our actual classes. So this is a class called interface controller, and that's that interface controller that you saw on the storyboard. And then a notification controller, which is another interface controller to handle a notification. So the classes live on the WatchKit extension, even though the instances of the interface controllers are in the Watch app. So it's a lot of talking back and forth that the watch sets up for you. So here's our main interface controller. This arrow that says main, that's where your app starts. So whatever interface controller you want to be first, you just drag this arrow to it. And when the user taps on the icon on the watch home screen, that interface controller is loaded. So we'll add some things to it. We'll come down here and I'll add a button. The watch, as I drag this on, there's no, it doesn't matter where on the interface controller I drop this. The whole thing is highlighted, I let go, and it gets put on the top because this is the first thing in it, so it goes at the top. If I put another button on here, now you see I can go below it or above it. You can't go next to it or anything. Let me expand this. So we have two buttons underneath our interface controller, and the order of those objects matters. So if I change this to say A, and just to say B, I put B above A over here, it switches on the screen. So this layout system is doing all this for us. You can influence it a bit. So if I take B and come over here to position, I can set vertical to bottom. And that's telling it, try to put this at the bottom of the screen. So it does that. So let me add a couple more things here. Put 4 labels on there. You'll notice it got bigger to accommodate all of the things on it. I can add a whole bunch more, and then it grows. If I run this app, whether this is an app called Bezel that I'm using to display the simulator in an actual watch band, it's highly recommended if you are presenting to a client, because instead of the janky iOS simulator window, they see this nice, beautiful bezel window, and you can change the watch band that you're using. I don't present to clients without it, because they will ask you, why does it go all the way to the edge of the screen? And the answer is because there's already a border on the side of the watch that you can't see in the simulator. And so if you put all of your stuff side to side, it will look good, but you have to see it in the context of the watch for them to understand it. So here's our interface controller, and I can drag, and that's the only side effect of Bezel, is that the simulator window has to go somewhere to forward touches to it. And it can't go there. But I'll put it down here, and that'll be fine. So because we had a bunch of stuff on this interface controller, it automatically scrolls for us. And the digital crown on the side of the watch will also scroll that, but you can't do that in the simulator. But just trust me, when the user scrolls on the crown, it scrolls the interface controller up and down. So I want to make this layout look a little bit better. I especially want these 3 labels to be next to each other horizontally instead of vertically. So I can come up to Editor, say Embed in Horizontal Group. And now these 3 labels are inside of a group. You can see the group here on the side set to be horizontal. So by putting them in this group, we're changing the way it flows. I can set over here the height of the group. Right now it's set to fit content. I want this to be a little bit bigger, so I'll say fixed. And 100 is too big, we'll say 44. And we'll give it a nice background color. So I've got these 3 labels in this group. But I want it to look a little different. So I'll select these 2. I'll embed these in a vertical group. And our 3rd label disappears. This vertical group, inside the horizontal group, its width is set relative to container, so 1. So it's going to fill the width of whatever it's in, which in our case means the 3rd label got pushed off the screen. So we'll say size to fit content. Now all 3 of our labels look nice. So I'm going to change this to laps. I'm going to change this to 5. So the app that I'm building as a sample app in the book, it's for running on a track. And what you do is every time you finish a lap, you tap a button and say, this lap is done. And it knows how far you've run and how fast you're going and all that stuff. So if you want to tell the user how many laps they've run, I'm going to go in here and change the font to be a little bigger on the number of laps because we're not going to get that big. So we'll do 5 there. And now I've pushed off the label on the bottom of the group and it gets cut off. So we'll change this one back to size to fit content. Oh, that's width. I meant height. There we go. But I kind of want there to be more room on the side of this group. It kind of looks a little bit too tight to the content now. So I could just make it wider and fix it that way. But what I really care about is how much space there is between everything. If I change the spacing, I can change the vertical space because this is a vertical group. Or there's insets. And insets let you push things around inside of it. There's a lot like HTML tables, like cell padding and cell spacing. They're still here, they just call it different things. So if I say like 16, let's say 8 and 8 for left and right. So now there's an 8-point border on each side of the group, and that looks pretty nice. And then this label, so the layout system does this group first on the left. And then it's horizontal, so it moves over, and then this label gets put in. It's set to be left and top for vertical and horizontal. So I'll change this to be centered vertically. And this is where maybe you'd say how much time you'd taken. So these nested groups are the way that you make interesting layout in WatchKit. It can get confusing, but everything is laid out visually using Xcode, so you can play with it and move things around.
Is there any way to mark the limits of every little label or controller or everything you have inside of it? Like a grid?
There's not a grid. Let me see. So on normal storyboards for iPhone, you can't hold. Sometimes you can hold Option in iPhone storyboards and see spacing between things. But no, there's no like snap to grid or anything. Let's see. The last thing to talk about here before we go back to the slides. I'm going to come up here and I'm going to say in the Assistant Editor preview. And now we see what this will look like on the actual watch, right? So this is going to come in here, and I can scroll it with the trackpad. That's a 38mm watch. Come down here and hit the plus, and we can add a 42mm watch to it. And you can see that even though it's only 4mm different, there's some extra space in here. Maybe too much space. Maybe this doesn't look so good left aligned on the big watch. So what you can do is come into this label, and this plus, I don't know if you can see it too well on the screen, but there's a plus next to that horizontal. Whenever you see that plus, you can hit tap it and hit 42mm and specify a specific layout option for that size watch. And so for 42mm, I'm going to center align that and it just moved very slightly. But I can also right align it. And so the same layout can look different on the watches depending on what you need to do. I'm not a good designer, so I can't make it look that pretty, but if you work with the designer and explain the system to them, you'll get great results. There are a lot of really good looking watch apps out there already.
Can you do that with using the size classing screen size thing down there too? On the left-hand panel, is there just like,
yeah, so if I come in here, I can say 42 millimeter, and then now these have all resized. And then if I take 5, let's say, and I want this to be bold, we'll say, here it is, style heavy. So that still changes it on both of them. They got bold on both of them, so you still need to use the plus. But you can at least see it over on this side as 42 millimeter. All right. Keynote, no. Just the basics of the interface system for WatchKit. It takes a lot of getting used to. The insets and the spacing on groups, you can position things exactly how you want. So for the app that I made, we have a center image in the screen, and then we have 4 images that need to be at specific places around them. So we have like horizontal group with a vertical group, an image, another vertical group, and those side groups use the insets to push things down towards the middle to fit around the image. It'd be better when I can tell you guys what that app is. I can show you, but yeah, once you play with it a little bit, it's a lot easier. So interface controllers. Yeah. Start this again. There we go. When you make them, they're kind of like self-contained little screens. And the life cycle is a lot like a view controller life cycle, but very compressed. You get an init method whenever it's created, usually in your storyboard. Actually, always in your storyboard, but depending on when it's shown. There's awake with context, and that's kind of like awake from nib on iOS. There's will activate and did deactivate. So view controllers have all kinds of lifecycle methods, like view will appear, view did appear, view will disappear, view did disappear, and you only get 2 on WatchKit. So you'll get a message and will activate before you're brought on screen, and then get another message when you've been brought off screen. You want to be really quick in these methods. So will activate, that method is called, and you'll see a spinner, little activity indicator on the watch, and it's not until that finishes that your interface actually displays. So don't do a lot of heavy duty work in there, or your user will get bored and hit a button and go back to the watch face. But no app should have just one interface controller, unless it's a really, really good one. So you'll want to go between them. There's 2 ways. You can do that in code or in a storyboard. The storyboard segues, so just like on iOS, you control, drag, and hook things up. Or in code, you can push them, present them, or reload them. It's kind of abstract, so I have another demo. Put that. Here it is. Here. All right. So this sample app got 3 interface controllers. This is the main one. It's got the arrow pointing to it, and it's just full of buttons. Oh, this is the final version. I should go back to where from before I did all this. So, let me delete all the code. And get a nice fresh slate so you can see this for the first time. Okay, so if I run this app, here's our main interface controller. It's got our buttons in it. And none of them do anything yet. We haven't hooked them up. The way that this main screen got that yellow text on its title, in the storyboard, you have a global setting for global tint color right here. So we set our global tint to yellow because the app we're making has a yellow UI. So easiest way to transition between interface controllers, move the main screen down to first page. So when you start the app, it just goes to the first page. So can't do anything yet. The easiest way to do it is I just control drag from this interface controller to this one, and then the relationship pop-up pick next page. So now, when I run the app, so when I run the app, so see the first page, I scroll over, now I'm on the second page. So I didn't have to write any code. It's kind of like a UI page view controller. There they are. Now, this show pages button, what that's going to do is that's going to show both of these pages, but in a modal presentation style. So they're going to come up above that page. So the easiest way to do that is to control drag down here. And in action, you can either push or modal. So we'll select modal on the app again. And hit show pages. And that first page comes up. There's the second page. Now you notice the title got changed to white. That's because this is a modal dialog. And if you tap on first page, it closes it. So it's kind of like presenting it modally on iOS with a close button at the top. And in fact, if I come in here to the first page and I take out the title, it won't do anything. Again. There we go. So if there's no title and you present it modally, it will automatically say cancel. So I've used this. There's no like UI alert view or anything like that in WatchKit. So if you need to tell the user something, it's a good way to do it. Next up, we want to just show the first page. So last time we control drag and set up a segue and a storyboard. This time we'll do it in code. This interface controller here is main interface controller. It's in Swift. And the way that you add action methods is just like iOS. Control drag. Why is that second page again? There we go. So I control drag from the button into my class. And I'll select action. We'll just call this show first page. So this is for iOS. You might be thinking, I need to create a new interface controller to present right now. So you might try something like, this is called first page interface controller. So we might try to just make one in code, right? Just create a new one and use it. And if I do this, put a breakpoint there. Oops. Use the simulator, it's easier. So when I say show first page, we hit our breakpoint, and we crash. Turns out you can't create interface controllers yourself. They always have to come from the storyboard. So the way you get to them is their name. So instead, I'm going to call present, actually I'm going to call push. So push controller with name. And I'll say for the name, first page. Context, we'll talk about contexts in a minute. That works because over here in the storyboard, the identifier for this controller is called first page. If you put an interface controller in the storyboard and nothing connects to it with a segue, and it doesn't have an identifier, you'll get yelled at because there's no way to get to it, because you can't make it directly. So now, we hit show first page, and the first page gets pushed onto the screen. And drag to the left and get back. Or I can tap that button and get back. Put the title back on here. Now this show second page, we're going to do this pretty much the same, except we're going to do this modally. So now I'm going to say present controller with name. I'll say second page. Now, so show second page. There's your second page. This one's modal, so I can tap on this to go back. Reload pages, we're going to have this do a drastic action. So in your app, let's say your first screen detects if there's a user logged in. So one thing you have to think about is, what if somebody installs my app and it's on their watch and they tap the watch and they have never once launched the phone app, so they don't have an account? One way to take care of that is by calling communicate interface controller reload root controllers with names. That takes the current UI and just replaces it entirely with something else. So you might replace it with a screen that says, hey dummy, you have to log in. Don't actually call your users dummies, but you can if you want. So we'll say first page and second page. And run the app. And we'll say reload pages. Now the entire interface is gone from before. All we have is first page, second page, and there's no way to get back to the user unless we do it in code. So if your app has like modes that you enter, that's a good way to force the user into one part. All right, finally we're going to do swap pages on the second controller. So say same method as before, but now I'm going to pass the second page first. So we reload pages. We have first page. We have second page. We have swap pages. We're still on the second page, but it got flipped because it just reloaded the whole thing with the second page being first.
Does that completely reload the second page, so reload all your assets and everything?
Yeah, so if I come in here and I'll say awake with context, I'll just log out. Every time one of these classes is created, that will get called. So if I show second page, we get one. If I reload the pages, we don't get one because that one's been reused. So there's your answer. It gets reused. All right. Any questions about transitioning between them? Yeah.
Segue data.
What's that?
Is there an idea of segues, or how do you get data in between the different controllers?
It's a very good question. It might even be the next thing I'm going to talk about. So you saw that all those methods took a context. And that is probably the greatest thing about interface controllers. So like pretty much every time you make a view controller on iOS, you will have a way to put data into it. So if you have an address book, there's going to be like init with address or init with person. If you have a pizza order, you might say init with order. And there's no way to do that in WatchKit because you don't create it yourself. You can't make a custom initializer. So that context parameter is just whatever data you want to pass in. So go back a little bit. So all of these methods take contexts. If there's only one controller you're passing, it just takes one context. And if there's multiple, it takes an array of them. So like the first item in the array gets the first context in the array, and so on and so forth. And that could be whatever object you want. So if you want to pass in a pizza order, you pass it in, and in the awake with context method of that interface controller, it will receive that object, and it can do whatever it wants with it. And then if you are segueing in a storyboard, there are a bunch of methods like context for segue with identifier that let you, when that segue is about to fire, pass in data to it. This is kind of a system level acknowledgement that most of the time you want to pass data into a controller. I like that a lot. So images, you put them in your Watch app bundle most of the time because that's the best performance place to put them. So you can call, for instance, set image named on WK interface image, and you just pass in the name of the image. You also make a group have a background image, which makes it look really nice. You would call set background image named. And in your WatchKit extension, if you have an image, let's say if you render a photo on the fly, you would just call set image directly or set image data and pass in the data to the image. Same thing for background images. Now, the big difference between these is that all this communication happens over Bluetooth or Wi-Fi, right? So if I tell an image to use an image with this name, the only thing I'm sending to the watch is a string that's the name. If I'm sending the entire image and I haven't shrunk it down to the size of the watch, that's going to be a performance problem, and your users are going to leave your app. So obviously, you only want to do watch-sized images being set. So make sure you resize them first. Most of the time, your images will just be bundled in the app because that's easier and faster. For animations, you'll want to put those in the bundle because it's just too slow to like send 60 frames per second over Bluetooth to a watch and expect that to happen instantly. So I'm going to put an image in this app here. Let's go back to the demo app. So I'm going to take all this stuff in here, just get rid of it, and put in a WK interface image. And we're gonna make this one, oops, we're gonna make this just fill the entire view. So make both of these relative to their container of 1. And I want the image, we're gonna call it Jeff. We don't have an image named Jeff, so we get a question mark. The thing is, it's going to be a full screen image, and so I have 2 different sizes, one for 38mm, one for 42. So I'm going to go ahead and preview this. Where did my... Weird. Okay, so there's 38mm and 42. So I'm going to go into my WatchKit app and make a new image set. We call it Jeff. By default, we just get this 1x, 2x, 3x versions for like Retina displays for the phone, but I want to put different sizes in for the watches. So I go to the attributes inspector and I go to device specific, uncheck iPhone and iPad, and now we just have Apple Watch sizes. There's a generic 2x, and then you can put special versions for either of the 2 sizes. So I'm going to come in here and I have an image prepared. I've got a 38mm version that I'll put right here, and 42mm version that I'll put right here. That's me. So if I run this, where'd you go? Where's my mouse? There it is. I run this and go to the simulator. Works just fine. There I am, taking up the whole screen. Life is good. I can quit this and go to the simulator and change to a bigger watch to the external displays menu. Make sure that's on the right screen. Now I'm huge. Now the image got used for the bigger watch. And all I had to do was specify the name of it and put it in here. But if I go to my storyboard, I still see the question mark. Because the storyboard right now is on any screen size. All it knows is it's going to be Retina, and so it doesn't know if it's 32 or 42, or 38 or 42. I can set that down here and preview what it's going to look like. But really what you're going to want to do, in most cases, is specify the 2x version and then just override that if you need to. That way you'll see it in your storyboard. There's my creepy eyes.
Does the 2x version translate to 38?
So if there's just one version, here, let me delete the 42mm version. So they will both use 2x if there's not a specific one for it. But what this gets us is if I set it to center. So in this case, you see there's a border around it because it's not quite big enough. So because we don't want to waste data and put an image that's too large on the phone on the screen, you can specify a different one. But you always want to have a 2x version, if for no other reason you can see what it looks like in your storyboard.
But it doesn't matter if you design for the 42, it can scale down.
So depends on what the type of image is. For the menu images that pop up on the Force Touch menu, they actually tell you to use different stroke widths. Like if you have a check mark, they say use 4 points for the small one and 5 points for the big one. So a lot of times you'll wind up rendering them twice. But if it's like a photo, then yeah, just scale it 2 times for whichever size you need.
Well, no, I was just saying that the recommendation would be the base image would be 38 scale 42.
Oh well, yeah. So for like a full screen image, yes. But if it's just like let's say it's a check mark for a button icon, you might not even need separate versions. So it's kind of just a way to override one of those sizes if you need to. Kill that. Okay. Tables. So all this stuff is kind of building up to tables because they take all elements of this and expand on them. We all know and love UI table view. Pretty much every iPhone introduction book uses UI table view to teach you about delegation. It's a weird concept. There's no delegate and there's no data source on WatchKit tables. The data source is just when you set up your controller, you just put all the data in the table. You just give it everything. And the delegate is always just whatever interface controller is there. So
is that the only place where you can use delegates?
yeah, so the only thing that can respond to a table is the interface controller it's in. That's just automatically set up for you. So it's kind of like every interface controller is also like a UI table view controller. You'll make row controller objects that just hold all the stuff that's in one row and then put the data in them. And those are just plain old NS objects. This is our fanciest demo. Over here, and where were you? Here we go. Okay, so I have this project, and it is showing me a list of people. So let's get to the storyboard, see what it looks like. So here is our interface controller, and here is our table. The table has one row in it, and that means there's one type of row we can show in a table. And we called it person row. And in that is a group. So table rows are just groups. We've got a name, label, and an image. And then a couple of buttons down here. So what this does is it shows everybody who was on my last project. So here we are in an array, just names. And when the interface controller loads, we call reset data. So instead of, so UI table view, it asks you how many sections you have, then it asks you how many rows are in each section, and finally it asks you to make a cell as needed for each cell. Here, we just say set number of rows, we give it the count of our array, and we say make those this type. That type is just that string person controller that we set in our storyboard. So once we've done that, we loop through from 0 to the number of rows, and the table, now just like we couldn't create an interface controller, we can't create the row ourselves. So the table is responsible for creating that row from our storyboard. So we have to ask it for the row. So the table gives us a row controller for that index. And if it's that our row controller class, we know there's a name, label, and then an image, and we set them appropriately. The row controller class is pretty dumb. It's just got a label and an image. And then in our storyboard, these are all hooked up. So this image is hooked up to the row, and that outlet gets filled. So if I run this, I should probably go to the app. That's not good. I was doing some fancy stuff with this earlier. Let me take this code out. Okay, so you see that spinner? It's loading all of our data right now. It has to wait until will activate finishes before it can show us anything. So right now, it's going through and getting all those images. So there we go. So there's all of our rows with that row controller. There's me, and there's my coworkers, and this background image in the interface controller that gets centered on everything. Now, if I want to interact with this table, say I want to tap me and remove me. There's a method on the interface controller, table did select row at index. So anytime you tap that row, it gets called, and then we can call remove rows and indexes and remove it. So if I tap on me, I go away, and we all start to go away. Then I have a reset button. There we go. So if you have multiple types of rows, let's say you have an address book and there's people, but there's also businesses, and you want to make a second row type, what that would look like actually, no, you would just go to your table, and in the attributes, rows is set to 1. So it's the number of types of rows. So I can add as many row types as I need to this table and give them their own classes. And then when I call row controller at index, it will give me the right class for that row. So it's kind of backwards if you use table views, where now you push everything and then do it all at once. But the reason for that is you wouldn't want a UI table view on a watch, because if it had to talk over Bluetooth every time it was trying to create a cell as you're scrolling, performance would be terrible. So instead, it just loads everything up at first, and then you can scroll, and it's all fine. So that was our last demo. Last thing, so no app is an island. And you're probably, because you're making an extension on an iPhone app, going to want to talk to and share data with the app that you talk to. If you're already using app groups for extensions, then you already can share data. So you go into your capabilities of the app and you use app groups. You can get a shared NS user defaults, and those work across all your extensions and your main iPhone apps. If you have like a Today extension, that's how you share data. If you don't have this set up yet, you have the joy of modifying 3 different provisioning profiles now, because you need a provisioning profile for the iPhone app, for the WatchKit extension, and the WatchKit app. So if you already don't love provisioning enough, you will love it even more when you're doing watch apps. If you're using the keychain, you need to get something out of the keychain. By default, things in the iPhone keychain are inaccessible when the phone is locked. And that's a problem for us, because if the user's on their watch, they're probably not on their phone. So you have to make sure when you save things to the keychain to set a security level so that they can be used when the phone is locked. And that may be a problem for your client, depending on what you're working on. And then finally, when we were making this app that we're making now, it was like the first beta of WatchKit. And we realized that the API we were using was too tightly coupled in the phone app to be used in the WatchKit extension as well. Like all of the iPhone UI stuff was mingled in with the APIs that was just not going to be able to be ported over to WatchKit. So we spent like 2 days. We started rebuilding the API from scratch in our WatchKit extension. And then it's like a Thursday, and another beta of WatchKit drops. And I'm looking at the release notes. And this method gets added. Open parent application reply, and it saved my butt. What this does, the first thing you pass in is a dictionary. And that can be whatever you want. So strings, numbers, all that. And that gets loaded into the main iPhone app in the app delegate. It's a new method to handle a WatchKit extension request. So that comes in. You read the dictionary that you sent in. You do whatever you need to do. So whether that's interacting with an API or mining a Bitcoin or rendering a complex image that takes a long time, you do whatever it is. And then the second thing is a block that you call when you're done. And you pass in another dictionary, and it passes it back to the WatchKit extension. So this lets you get around a lot of things. For instance, HealthKit is not accessible to extensions. If you need to save something in HealthKit, it's not going to work unless you do it in the parent application. So that saved my butt. And it's really useful for any kind of long-running task. All right. Yep.
Does that block the thread of execution waiting for the reply?
No, it doesn't. So you call that, and then the parent application will call the reply block.
Oh, so it's blocked.
Yeah, so it's asynchronous. And in the parent app, you always want to make sure to start a background task as soon as you start handling that, so that you can let the system know, I'm doing work in the background for the Watch app, even though I'm not open right now, and you won't get killed.
Sorry, I thought you were both fixed.
So the dictionary is passed in here, and this block takes a dictionary that the parent app sends to it. That's my last slide, so I can actually show this now. So where's my mouse? Here we go. So this is the app I'm making for the book. It's called Tapple App, because you tap a lap. And when you end a run, a lot of things happen just because it's a book and I want to show things off. One of the things that happen is I save run to HealthKit right here. So I can't talk to HealthKit in the extension. If I try, so say import HealthKit up here. And then I'll say, make a new HK workout. I'm actually just going to copy and paste this code if you don't want to see it. Turns out HealthKit is very verbose. So put this HealthKit code in our WatchKit extension. I'm going to build this. Oh, that shouldn't have worked. So what we should have seen, where is it? Okay, well, anyway, I don't want to bore you finding. Anyway, HealthKit is unavailable to extensions, and there's some annotations on the source code that say like NS extension unavailable iOS, and it should be barking right now as I try to make these classes. But because the parent iPhone app can talk to HealthKit, I package everything up into a dictionary. So the key is run to save, and then I make a dictionary representation of it. And then I open the parent application with this user info and get a reply back. In my app delegate, there's this method, handle WatchKit extension request. And that's first it starts a background task, and then it saves it. So we save the run to HealthKit using all this code. And finally, when we're done, which is all the way down here because it turns out HealthKit is really verbose, we have this reply block that was sent in the WatchKit request, and we call that with a dictionary that just says success true. So we run our code, we call the block, we come all the way back here with that dictionary that we passed. So it's a way to let multiple classes handle things, and your app delegate can do a lot more than your WatchKit app. That's the basics of WatchKit. I can answer any questions or explain anything that's confusing. That's a very high-level tour of what you can do. And thanks for coming.
Can you show glances?
Oh yeah, glances. I was going to do that. Yeah, so let's go back to our demo. A glance is just an interface controller. So it's down here, glance interface controller. You can only make one, and they have two groups. And let's go here. So you get the upper and the lower group. And you can add whatever you want to them. So let's add, just to be quick, we'll add, can't add a button, but we'll add a label and a label. I'll say bottom. We need a class for this. So that's a new class, and it's just WK interface controller. Just like anything else, it's an interface controller. And we'll set up the class here. Our glance interface controller is set up, but how do I get there is the question, right? Because there's no watch face in the simulator. What you actually do is make a new scheme. So I'm going to duplicate our app scheme. And I'm going to call it Demo WatchKit App Glance. In here, there's the watch interface. So you can do main, glance, or notifications. That's how you test out your notifications. So now if I run, it will go right to my glance. There we go. So you don't see other glances. You can't swipe back and forth between them because the simulator does not have them, but you can at least see your glance. If you tap on it, tapping on the glance opens the actual watch app. You can't put buttons or anything inside the glance because just that tap always just opens your app. What you can do is use handoff. So there's a method to update user activity. You can describe what the user is doing, and then when you tap on it, your main interface will get that user activity. So you can go right to whatever screen your glance is associated with.
As far as interacting with the UI on the watch, have you noticed, say someone wants to make a screen where you can enter a phone number and put a bunch of buttons on there.
Yeah.
I was noticing where after you tap on one or two of the buttons, it doesn't say you wanted to update a text box or something like that. What's doing it?
I haven't seen that, but I have seen a lot of lag on the simulator, which I believe is intentional to give you a better idea of what it's like communicating over Bluetooth. You might double check you're doing everything on the main thread, typical kind of UI stuff. I haven't seen that. Text entry is difficult. I didn't show this, but so there's no keyboard on the watch, and we don't want there to be a keyboard on the watch. You can present a text input controller from an interface controller. What is Xcode doing?
Come on, you made this part without a demo problem.
I just force quit Xcode. So when that comes up, I already have this demo written. So where did the Xcode go? There it is. We have 1% battery left, so we're gonna make it. Oh wait, that's not the right demo. Come on. So in our tables example, there was an add button. And an add button, presenting a text input controller, and you give it suggestions. So the suggestions I gave right here is just our data. So the same data that built that table. You pass in an array of strings, and the user can dictate their own text to put into your app, or they can choose from the suggestions in the list. So you can't actually make a keyboard. Come on, Xcode. We've been very lucky so far with Xcode. All right, I'm going to kill this